You might know Liquid Haskell already. Is this static verification tool to which you read one program and a specification, and it verifies that the program behaves as specified. So in this talk, I'm going to try to convince you of two statements. The first statement is that Liquid Haskell can make Haskell better, and that is by way of offering support to avoid mistakes when writing or modifying programs. And the second statement is that in order to succeed at this, we are going to need the help of the GHC developers. So Liquid Haskell is integrated with GHC to some degree, and whenever there are changes in GHC, Liquid Haskell needs to be updated, and here we need the help of the GHC developers to anticipate or to identify problems that might come in the integration. So in this talk, we are going to see at how Liquid Haskell depends on the GHC API, and I'm going to discuss a few ideas of how the teams could collaborate in doing the updates quicker. So to see how Liquid Haskell can make Haskell better, we have to look at what Liquid Haskell can do. There's a range of things that it can do, from most modest to most ambitious. So let's start with the modest. Liquid Haskell can verify that invocations of partial functions don't fail at runtime. If we have to get the first element of a list, well, Liquid Haskell can ensure that the list is non-empty. And if we need to get an element from a container, well, Liquid Haskell can ensure that the position in the container where the element is supposed to be actually exists. Another use case is safe pointer arithmetic. So Liquid Haskell can ensure that the pointers that are used in our programs are valid. And here valid means that the memory that these pointers refers to has been allocated, and therefore is safe to read and write without producing undefined behavior. And yet another use case is verifying invariance of data structures. So Liquid Haskell can ensure that all the data structures that are used in a program are actually valid. And here valid means something different for each kind of data structure. So if you have a binary search tree, or you have a binary heap, or a custom data structure, then each data structure has a different notion of validity. And Liquid Haskell is flexible enough to accommodate all of these notions and use the appropriate one each time. So these use cases are described in this paper, which also has a couple of case studies, one for verifying an implementation of red-black trees, and another one for verifying data structures in the XMonad tiling window manager. So now going to a more ambitious use case, Liquid Haskell can be used to manage optimizations. Suppose we have a simple function that has become a bottleneck in a project. Then over time, developers come and implement optimizations that preserve the behavior of the function, we hope, but make it run faster. Now, optimizations have the unfortunate effect to make the code harder to understand. So when enough time passes, the function might become so complicated that nobody dares touching the code again, because it just might break, and nobody has a precise understanding of how the function should be modified. And this is why earlier this year, Conal Elliott was arguing that optimization is self-defeating without proof. Meaning that if we had a proof that the implementation is equivalent to the original function, then we could optimize the implementation by also updating the proof and getting a guarantee that the behavior hasn't been changed. Now, Liquid Haskell can help deriving this optimized implementation and check every of the steps of the derivation. And I also gave a talk last year where I demonstrated the point with a complicated function in the base library. So another use case is using Liquid Haskell as a stronger type checker. There are aspects of the programs that are difficult to express with the Haskell type system alone, and sometimes Liquid Haskell specifications can make this easier. This is a post discussing how to use Liquid Haskell to describe the type of well-typed lambda terms. And there's another use case in the works that is trying to use Liquid Haskell to give types to expressions or to values that are in a foreign language. We have a few more use cases. I'm going to go over those just to give you a broad idea of what Liquid Haskell can be used to. It has been used also to prove that the memory and the CPU that some functions use is bounded. It has been used to verify that web applications don't leak information to unauthorized users. It has been used to prove properties of distributed computations, and you get some guarantees about the global behavior of a distributed system. And lastly, there are some use cases that haven't been explored yet, but which are, it's plausible that they could be supported in some future. So why is all this important? Why would we be interested in making Liquid Haskell succeed? And the thing is that Liquid Haskell is not a tool designed for a specific use case. It's a tool that can inspire solutions in a wide range of domains. And it gives the opportunity to tap into the creativity of the Haskell community, like to explore all those domains. So this would enlarge the range of things in which Haskell can grow and be applied. Another motivation to try to have Liquid Haskell succeed is that it offers different trade-offs than traditional approaches to dependent types. And if we have these different trade-offs, then this is likely going to lead to different innovations when compared to the current trends. And one last motivation is that there are industrial applications that are within range or within reach, and so we could develop Liquid Haskell while addressing these industry needs and get in return some support for maintenance. And so this is why I think it's worth giving Liquid Haskell a shot. Now perhaps this is a good time to answer questions if anyone has any thoughts. Yes.
Dumb question.
Yes.
Can you use Liquid Haskell to prove that you can elide array bounds checks?
Yes, that's in the category of partial or verifying partial functions, right? That they don't fail at runtime. So with
Has anyone done it? Do you know if it works well?
yes. There is a talk by Gabriela Gonzalez from 4 or 5 years ago in Haskell Exchange, where she goes through a concrete use case of using Liquid Haskell to speed up a parsing library for UDP packets. And yeah, that's exactly a case of removing runtime checks and relying just on Liquid Haskell to check things statically. All right, any more questions?
Are you coming to an end, or have you got more to say?
No, I have more to say.
If you have more to say, fine, I'll wait.
Okay. So on to the next question. Why do we need the help of GHC developers? So
That was my question.
I'm going. We need to look at how Liquid Haskell uses the GHC API to answer that. So at the moment, the specifications of Liquid Haskell live inside special comments in GHC. So one first thing we need to use the GHC API for is to extract the comment from the source code. And then when we are going to analyze a module, we need to understand what the imported functions in that module are, or how they are supposed to behave. And this requires learning their specifications that are stored in the interface files of the imported modules. So we need to use the GHC API to load these interface files and get the comments and the specifications from there. And Liquid Haskell is going to analyze GHC core. So we need to issue our Haskell to GHC core in order to run our analysis. And then when we have GHC core, we run the analysis, we produce a list of proof obligations. And if all these proof obligations are going to be given to a theorem prover, if the theorem prover is satisfied that, or can prove all of them, the module is set to pass verification. But if some of the proof obligations cannot be proved, then we need to report some errors to the user, and we are going to use exactly the same interfaces that GHC uses to report compilation errors. And one last use of the GHC API is to store the specifications of our module in the interface file. So modules that import our module can learn what the specifications our functions have. And it's part of maintaining Liquid Haskell is maintaining these uses of the GHC API. And there's a problem, which is that Liquid Haskell is like near 3 versions behind GHC, the last release of GHC. And whenever there are changes in GHC, usually we have to make changes to Liquid Haskell. And the last time we did this was for version 9.2 of the compiler, and it took around 10 days. So it's quite some effort to update Liquid Haskell now to the latest version of the compiler, and we would like to make Liquid Haskell quicker to update. So, but there's a challenge, which is that the information necessary to do the updates of Liquid Haskell is distributed between the Liquid Haskell developers and the GHC developers, and we would need to get that information together into the same heads. So, from the GHC developers' perspective, if a change in GHC breaks Liquid Haskell, it's going to be a challenge to figure out how the old behavior was used in Liquid Haskell, so it can be recovered or replaced. And Liquid Haskell is quite a piece of software. The part that interacts directly with the GHC API is 30,000 lines of code. But if the change in GHC is subtle enough, a debugging session is probably going to send the developer into all of the components in Liquid Haskell. So this is not a very bright perspective, I think, for GHC developers.
You did 30,000 lines of code directly interact with the GHC API?
Yeah.
Ah.
Yeah, that's like the bulk of the code that does the analysis of GHC core, and that's all the uses that I listed just now. Okay, so so from the perspective of the Liquid Haskell developer, instead, it knows exactly how the old behavior of the GHC API was needed, and it also could evaluate quickly if a new interface could be used to replace that behavior. But what it doesn't know is exactly how the GHC API has changed, and it doesn't know exactly what concrete interfaces are available to replace or to recover the old behavior. And this is where we need help from GHC developers, and where we would need some. We need to solve a communication problem. This is not so much a technical problem as a communication problem between the teams. So an effort to stabilize the GHC API would help, but I think we can do we can take smaller steps, like to address a problem. For instance, suppose that we collected a list of all the functions from the GHC API that Liquid Haskell needs. Now, whenever this, and when we collect the list, we could also collect the types or the type signatures that we expect of these functions. And whenever there's a change in the compiler, we could expect to automatically know that something has been broken. And this could, and then either team could start a conversation about how to resolve it. Moreover, this list will inform API stabilization efforts. So people doesn't know to browse all of Liquid Haskell to learn how it depends on the GHC API. Another step in this direction is to write tests for specific assumptions about how the functions behave. Liquid Haskell has been sensitive, for instance, to how case expressions are desugared. So if we write a small test that says, well, this is how Liquid Haskell is expecting the sugaring of case expressions to happen, then when that assumption changes, we can discover it quickly by running the test and seeing that they fail. Also, for a GHC developer, it's easier to understand how Liquid Haskell depends on the sugaring by looking at this test instead of having to figure out how the Liquid Haskell tests have failed.
So it sounds like you're really depending on more than just the list of GHC functions and types, but also something about the semantics of the compiler itself, how it translates Haskell into core, I guess, right?
Yeah.
That's a bit harder than, I guess, the just API guarantees.
Right.
Yeah. Okay.
Yeah, but it's going to save, the point is to save debugging effort. So we don't need to debug the Liquid Haskell test whenever these assumptions change. So I think Simon has a question back there.
So I think this would be really helpful, actually, because we've for a long time we've aspired to have a project to define the GHC API, and here's a concrete use case. And we don't have to define all of it. Just defining the part that you use would already be a step forward. But it's more than just a routine question of listing all the functions that you happen to call. Because I'm sure that what you've done is you've just reached out and grabbed the function that seemed most plausible that day, right? And because that happened to be available. I suspect there might be a more active process about saying what function would we like to have, and its semantics. So we happen to have reached out and got that one because it's available. What would be perfect would be to have this, right, which would replace these three others. So I think it would be more than a routine matter, even on your side, to define what is the API that you want.
Yeah.
But it would be a very valuable exercise. It would be really helpful to us.
Yeah. I think before engaging in this conversation, I'm going to just go on with the next slides because I think, yes, we need to complement these ideas still with some more dialogue about how to use the GHC API. And all right, so this is the idea about the assumption test. And another idea in this direction is to run this test periodically somewhere, but then we need to agree how to respond to failures in these tests. And one idea here that I think could work is if the GHC developers maintain a log of where each entry is going to explain where for this test failure in assumption test, this is what the Liquid Haskell developers could do to recover the old behavior, if that makes sense, if recovering the old behavior makes sense. Or rather, the Liquid Haskell developers should really be using this other interface to accomplish this task. And note that this idea generalizes to any client of the GHC API. It's not just about Liquid Haskell. And also having test suites with assumption tests is like we will have focusing what's the documentation effort that needs to be done in order to stabilize the API, because if nobody's test is being broken with a change, there's less of a motivation to document it. On the other hand, if we know that some expectation has been broken, then perhaps it's fine to leave it without further comments. Okay, so I would like to finish with a small perspective. Oh, we have a question. Please.
Just propose.
Uh-oh, I don't know.
Try now. Yes.
Well, I think I can repeat the question anyway.
Okay, yeah.
Okay.
Do you think it's possible Liquid Haskell CI to be integrated into GHC CI? So if someone breaks the behavior of GHC, or not breaks but change the behavior in GHC, it will fail Liquid Haskell CI directly, and this will report Liquid Haskell team directly. So if both CIs are integrated, I mean, better Liquid Haskell CI into as a steps into GHC CI. So all the merge requests in GHC will be tested via Liquid Haskell CI, and this will be another test for GHC. I don't know if this is feasible, but maybe you both could talk about it.
Yeah, I think that maybe adding all of the tests of Liquid Haskell into the GHC CI is not a good idea, because you need so much knowledge about Liquid Haskell to understand why such a test is failing. That I think we wouldn't want to stop Liquid Haskell developers from making, or we wouldn't want to stop GHC developers from making progress because CI is red, right? So it's more like, but I think we can provide this assumption test that should be smaller and only mess with the GHC API. So there should be no specific about Liquid Haskell there. And when these tests break, GHC developers shouldn't be forced to fix them, but they should just comment on how they think they should be fixed.
It could be optional test.
Yeah.
Not to break the GHC CI, but it will show that something is broken by the changes, by concrete changes in GHC.
Right. Yeah. So it's some arrangement like that.
On small steps, because not on the later when there are a lot of changes in GHCI, and you to try to fix Liquid Haskell over the whole chunk of changes, and it could be fix it on smaller steps, which will be much faster to fix in early stages. Shift left approach.
Yeah.
There's precedent for including such packages in head.package, for what it's worth.
Mm-hmm.
And there's another question.
Yeah, is this on? Okay. Anyway, just following on to that, can you hear me? Yes?
Yep.
Okay, great. I'm hesitant to add more to the GHC CI because we don't even have enough CI capacity for like the JavaScript backend's performance build, so don't expect performance just yet. But also, couldn't the Liquid Haskell project pull down GHC nightly builds and then test their CI with the GHC nightly?
I suppose so. Yeah. But I mean, let me make this clear. It's not difficult to come up with a scheme to run the tests and to monitor when they fail. So I think the real difficulty is how do we fix Liquid Haskell then quickly, right? Without doing too much debugging and too much figuring out of what has changed in GHC. So I think for the sake of time, I better finish my slides, and then if there are more questions, then we answer them in the hall or here if we have time. All right, so to finish, a brief perspective of the evolution of Liquid Haskell. It started as a verification tool for OCaml, actually. Then it became a verification tool for Haskell, and some years ago it became a GHC plugin. And the experience with the GHC plugin, I think it has been fantastic when compared to the experience before, because the GHC plugin allows to share specifications across packages, and it also delegates to GHC the problem of deciding in which order to verify the modules, because you need your dependencies verified before you verify the module. So it has been great. Also, the GHC plugin is very handy to fix Liquid Haskell, rebuild it, redeploy it, and this works in absolutely any Haskell project. Right? If Liquid Haskell were further integrated with GHC, then we would have to fix the compiler, rebuild it, redeploy it, and I think this is more of a challenge in general. Or perhaps sometime in the future, we still could keep the advantages of the GHC plugin, but still get a Liquid Haskell closer to a language extension, perhaps deploy one day together with a compiler, so it's easier to try and to adopt. But I think the advantages today of the GHC plugin are a serious thing. Whatever the path we decide to go further, I think the communication problem is going to remain and needs to be solved. And with this, Now it's your turn to lecture me on how you think that our teams should collaborate. Thank you.
So from my perspective, I think there definitely are a few things that we can work on together here, and I think a lot of this comes down to, as you said, starting with a concrete list of things. This is interfaces and assumptions, and starting to work on making those into something that the GHC team, adding essentially. Historically, the GHC developers have treated the GHC module itself as the GHC API. Anything beyond that particular module named GHC in the GHC library is sort of internal to GHC and not to be... yes, okay, sorry. And not to be treated as stable. But of course, you can do very little with using only the things in the GHC library, the GHC module, that is. And that's something that we've long needed to improve. So having a list of things that we can start to sort of consider, okay, maybe these exact interfaces aren't the things we want to add into the GHC library, since they may be unstable or they may not have quite the right semantics that you want, but at least that gives a starting point for discussion. I think the HF as well is, David Christensen is working on finding people to resource a effort to actually stabilize some subset of the GHC API and work with projects exactly like Liquid Haskell to make this an API that's usable for users. So that it would be a really, but in the short term, I think just we should start by opening a GHC ticket and starting the communication there, and try to hone a concrete list.
Looking forward to that.
One last question.
I just wanted to mention, with respect to the Haskell Foundation project, I mean, this is something that I've, obviously, David is now moving on to other things, but this is something that just in the past few weeks, we've been talking about very explicitly. And it would be great if it were a little farther along for this particular event, but we definitely want to kind of start by just putting together a sort of, I don't know, committee has such a bureaucratic connotation to it, but just a group of people, a group of people who are actively trying to do things like this. And I think it's challenging because, for some people who want to get information out of GHC, it's like, things like Google, right? The interface can be very thin, whereas for things like template Haskell or Liquid Haskell, it has to be a lot. You were saying you depend on how case is desugared.
Yeah.
And so for stuff like that, I do think it would be really, really helpful, as Simon kind of mentioned earlier, to think about what, in an ideal world, would this look like? Because I think in the past, our approach to trying to create a GHC API has just been to say, well, we've got this stuff sitting around in GHC, and we can just expose it. But this doesn't really work very well, because then things break, and you depend on implementation details. So it would be very nice to have some, greenfield API that can serve that sort of use case.
Was that the question?
Well, I think the question is asked to the audience.
Yeah.
Well, I think in the interest of time, I have to cut that short. Thank you again, Facundo.